Hi guys, welcome back. So in this chapter we are going to talk about flowcharts. If you remember, in the last session we completed up to operators. We have seen arithmetic, relational, logical, correct? Now let's talk about flowchart. What is flowchart? Flowchart is primarily a graphical representation of an algorithm, a picture which depicts the computational thought process. Why do we do this? Because we all know a picture is worth 1,000 words. Now, who and all use this? Whoever wants to create a plan and they want to communicate it to multiple stakeholders. Stakeholders means people, different kinds of people who are involved with the project. Now, for all of them, we need to create a blueprint. We need to create a documentation. Now those people need this flowchart. Over and above that, we also have people who are going to work on the software. We call them as developers. They also need documentation. Plus, we also need to have these documents given to the testers, analysts, to analyze the solution which we have created. So primarily my flowchart is going to be my base document. Now the question is, how do we create this? Flowcharts are a combination of many symbols which depicts the process. Now here we have few symbols. You could see the oval symbol represents the start or end. The rectangle symbol represent a process which happens in the system. That is the logic, we call it as. The diamond symbol, we also call it as a decision symbol, represents a true or false scenario, a decision making scenario. The polygon, where we depict an action. Now most of you will have a confusion between process and action. Action means the job which the user performs or the application performs. Mostly input, output are two very important jobs which the application will perform. And then the flow line, which depicts the direction of the application flow. Now these are clubbed together to form a pictorial representation of your algorithm, the step-by-step process to carry out a task. In the right side, you could see a simple algorithm being depicted as a flowchart. So you got a start and a end, which is compulsory for every flowchart. And then the actions which you have, and also the steps which are involved. The could see there, you got a polygon where I am accepting a number. And then you got a process where I am trying to do an addition, and then I am doing a find action again, print, and then end. So simple process where two numbers are added. Now let's understand what are all the different types of process which we have. Now please understand, in any programming, we know already we have input, process and output. Process will definitely be the programming logic, and mostly it will contain two things. One is condition, one more is the iteration. Condition, one more is iteration. Condition is where you take a decision. If, else, if, we also call it as. If this condition is true, do this, else do this. So you call this as branching. This is the main thing in a process. And number two, iteration. Iteration means repeated execution of set of steps until the condition is met or satisfied. Like for example, I go to the market, I continuously buy the vegetables until the list in my hand given by my mother is completed. I study all the questions which are needed for the exam until I complete all the questions. So looping or iteration we call it as. So any program will obviously have conditions and iterations, which are basic fundamentals of any program. We also call this as programming constructs. Now coming to the technical details of this, please understand programming is pretty simple. That's the reason we are able to understand this so easily. You got only three types of loops, iterations. One is called as while loop, one more is do while loop, one more is for loop. So conditional construct is if else if. Now while loop, do while loop and for loop. So while loop, you could see you got a condition. If the condition is true, do execute. Like for example, if I go to a cinema theater, if I have the ticket, if ticket is available or ticket availability is true, I am allowed to watch the movie. So I keep on watching the movie, fine, and then I come out. Or I have a bus pass. Until the bus pass is valid, I can keep traveling the bus. While condition is checked before, like in a cinema theater, the condition is checked before you enter into the hall. Do while is the loop is run once and then the condition is checked. So the primary difference, if you look at, do while loop runs at least one time, whereas while will not even run one time if the condition is not satisfied. These are the different loops we have in iterations. So you could see here, do, after that a block is created using the floor braces, which is a programming construct, and then while, and then the condition. Is that making sense, guys? Fine. So if the condition is true, again the loop continues, If the condition is false, the loop breaks. So difference, please understand. While loop runs only if the condition is satisfied. So if the condition is not satisfied, the loop may not run itself. Whereas do while at least run once, even if the condition is not satisfied. So if the condition is false, it comes out. If it is true, again it continues. And the third very important loop we have is for loop. For is a iterative loop used when you know the exact number of iterations which you want to perform. Primarily you use while and do while for a infinite loops, whereas here we use for loop for finite loops, where we know a condition and we iterate until the condition is satisfied. See, for example, I can have an initialization, and then initialization, int I equal to 0 can be initialization. Condition, I is lesser than 10. Iteration, I plus plus. You already studied all these things, correct? Now until I reaches 10, the loop will run. So primarily for finite number of loops, you can always rely on for loop compared to while loop or do while loop. But again, let me assure you, all these three loops comes under the concept called iteration or looping constructs. Now that we have seen this, it's high time now we start understanding some of the algorithms and the usages of this condition and the looping constructs. So we are going to demonstrate few exercises here in this first chapter. So here I am going to talk about how you can sum 5 numbers. Now likewise we are going to see few exercises in this. See, the algorithm in simple English, it says initialize sum equal to 0, count equal to 0. Fine. This is a step. So you could see here I have a process, and then I have enter n, a IO, action. A IO is an action. So that's entered as a polygon. Could you see this? We are learning flowchart. And after that, find sum plus n, which is a process. So sum equal to sum plus n. Sum is 0, 0 equal to 0 plus n. Let's say if the n is 5, this sum will become 5. Sum will become 5. Correct or not? n is fine a number plus 0, which will become the number, right? If the number is n is 5, then sum will become 5. Now I am increasing the count from 0 it becomes 1. I am checking whether the count is lesser than 5. If yes, again I enter the next number. So again he enters 5. So it will go sum plus n. 5 plus 5 equal to 10. Now count is 2. Now then again sum. Again count increases. Again sum. Again count increases. When it reaches 5, 5 is not lesser than 5. Fine. So immediately it turns out as true. Or like no, see, is count lesser than 5? No, 5 is not lesser than 5. So no, it comes print the sum stop. Now this is a brain mapping which we have done. You could very well understand what your brain is doing, but first time you are seeing what your brain has done in the form of a flow chart. As I said, a picture is worth 1,000 words. Just look at it, guys. You are able to visualize what your brain has done. This is the power of flow chart. Now, as students of this IIT-BS qualification round, see, please, I will give you many exercises like this. You need to first practice. This is your first chapter in which you have learned the basics of computational thought process. Now we have come to these flow charts. Now let me show you these exercises in a practical way. Again I am saying I am not trying to teach you Java or any programming main language as such. I am just trying to teach you basics of programming. So don't worry about the program and the execution, all these things. Just understand the concept. Sum of elements. Just now I have showed you a flow chart. So let's do that. So here I say int sum equal to 0, int count equal to 0. So I want to accept this from the user. To accept this from the user, there should be some way. Scan equal to new scanner. Don't worry about all these things. These are programming techniques by which in Java you can accept. So how do I want to accept? I want to accept many times. So how many times? Until the count becomes 5. While, or rather in this case I want the loop to run at least once, right? So I will say do. Here I will say count is fine lesser than 5. While do, while count is lesser than 5. And here I am going to accept the number. How? Int n equal to scan dot next int. Now this is basically to accept the number. No sir, I don't know scanner. No, I am not trying to teach you Java. Please understand. I want to teach you that there is something called a process, action, and then some output. That's all. And I want to teach you algorithm here, not to teach you scanner or next int. This is accepting a number from keyboard. If you understand this much, it's enough for as of now. And now that you have accepted, now all I am going to do is sum equal to sum plus n. So whatever value you have given, it will. Now I will say count plus plus. You know very well, count equal to count plus 1 or count plus plus. Both are same. So this will continue. Once it is over, fine. Once the count comes to fine 5, it breaks. The loop will break. Now I will say the sum is. So I am just trying to print the sum. So if I am going to run this program, so I don't want you to worry about the complex programming here. I just want you to concentrate on the algorithm and the simple things which are said in this program. So here I am supposed to type, let's say 5. Now I enter 5, enter 5, 5, 5, See, sum is 25. Could you see that? In fact, if I want, before I give, I can also give enter a number so that it makes sense. Say this. Every time it will ask 2, 2, 2, 2, 4 times it does. Fifth time I'm asking, so it gives me sum. Could you see that? This is your first algorithm. If you want, you can also type and check this out. There are a lot of places. I'll show you some places. Okay. Now, apart from this, what are the other algorithms we have, sir? Let's look at them also. I have some algorithms where in the first algorithm I am finding the greater number, and also I am written an algorithm, a flowchart for odd or even number. Let's understand that. I am accepting two numbers. Fine. And if I am checking if A is greater than B, I will say first number is greater, or else I will say second number is greater. Makes very simple. Fine. I would like to do this program on internet, on a website, which you can also try it out. See, there is a site called as pythontutor.com. Go there. Here you have a place where you can type. For example, see this. So I can go to pythontutor.com. You have so many languages. I am choosing Java here. So what you can do is, in order to test my code, you can say like this: public static void main. See this. I'll show, because you may not have Visual Studio, you may not have Eclipse or STS tools to check Java, JDK. So you may just have a simple computer. Just go to this site and you can try Python, JavaScript, C++ code. Any code you can try it out. Say for example, here I am saying int n1 equal to 10, int n2 equal to 20. I can type if n1 is greater than n2. I am saying system.out.println first number is greater, else this is the condition for, this is how the conditions are tested. So here system.out.println of second number is greater. Now if you run this, visualize execution. The beautiful part of this is you can see the execution in a visual way. See here. Okay, there is a bracket missing. Error came, right? Okay. See this. So next is there. See, first you can see the arrow red. It's a beautiful visualization tool. n1 is 10. Then you are saying n2 equal to 20. Then you are checking the condition. Fine. First number, that condition is gone. So second number is greater. Cool. You can actually see what's happening here. Let's see one more exercise. I press the back button. This time I want to use whether a given number is odd number or even number. That algorithm I want to use. So let's say int n1 equal to 13. So how do you know whether a number is odd or even? If the number is divided by 2, if we get the remainder as 0, then it's a even number. If not, it's a odd number. Correct or not? Fine. So here I can say, how do you get the remainder? Using the mod symbol. n1, 2. fine, is equal to 0. Then what do? I say system dot out dot println of even number, else, see this, system dot out dot println odd number. So a simple program. So I am checking whether the given number is odd or even. Now let me run this. Oh my god, again I have done the same mistake. Okay. See here. So next 13. So the first condition is not satisfied. The second condition has come. Simple. So here we have run one more program. Now let's see some more. So cool, we're able to understand these two. So sum of 5 numbers, then we have experimented on greater number and also odd or even number. Simple programs, guys. Don't make it tough. Don't think it is tough. So next is sum of an array. So I have n number of elements in an array. I want to add all the elements of the array. So what I have done is I have already pre-written that sum of elements in an array. See here, I have declared an array here and I am using a for loop. I could use while loop, do while loop, any loop I like, but I know the size of the array, right? So the best loop which I can try is a for loop. So for int I equal to 0, I is array dot length, that is the length of the array. So how many ever number of elements you have? Let's say 10, 20, 30. So 60, right? Total sum. So this array dot length will be 3, I plus plus. So now what happens when it runs? Array of I means index, each one is read through the index. So array of 0 is 10, array of 1 is 20, array of 2 is 30. See, I value is 0, then the loop runs, array I will become array of 1, array of 2, like that, correct or not? So first I equal to 0, then it checks whether it is lesser than 3, the size of the array is 3, then I plus plus. I plus plus will not happen immediately, so it will come to the loop. Sum equal to sum plus, this is a shortcut, right? Increment operator. Sum plus array of I. Sum is 0, 0 plus array of I. Array of 0 is 10. Now again the loop runs. Now 10 equal to 10 plus array of 1. Array of 1 is 20. That will become 30. Similarly, next it will become 60. So let's copy this and go to our Python tutorial site. See this. So let's run the visual execution. This will be very, you can see that how the code is running. See this. First the array is shown. See, this is the best part of this site. You can visually see what's happening in the algorithm. Then next, so sum is declared as 0. Now comes a for loop. So for loop I value is 0. So now some value will change. Some value will become 20. Again the for loop runs. So I value will become 1. So array of 1 will be 20. 20 plus 10 will be 30. Now again the loop runs. I value will become 2. Array of, see, array index always starts with 0. It is 0, 1, 2. That's how all programming languages, all programs will work. So now say next. So it becomes 60. So I is lesser than 3. I has become 3. So the loop will break and it will print the sum of elements as, see, 60. Got it? Am I making it simple, guys? Okay. Now let's move to the next algorithm. Find the maximum element, that is, find the highest number in the array. So for that also we have a simple algorithm. Now that photo is there. Let me show you the photo first. I mean the flow chart. See, this is the flow chart. So I have an array, then I say set x equal to 0, max equal to 0. I iterate until I reach the end of the array. Fine. If I am checking for a condition, yes, no, I am checking for the max. If max is not what I have is bigger than what the value is, the loop will continue until we reach we get the maximum number. Now this we will understand it very well in the program rather than the flow chart. So let me quickly go to the flow chart. I mean the program basically. So I have the logic. It's very difficult to understand here. So I would like to put it in Python tutor to make you understand it better. So I will execute here. Just a dry flow chart will be difficult. Dry code will also be difficult. But you run this dry run, this will make it simple. So first thing is we have declared an array. So array, you know very well, 70 is the biggest number. Now how do we do this? So here, this is not needed. Let me throw it off. I'll make it simple. So max number is, I'm taking the first value as the maximum number. So first value I'm reading as the max. Now I'm saying int I equal to 1, I is lesser than array.length. That means I want to loop around the entire array, I plus plus. I'm checking whether array of I, that is 5 is greater than max. Yes, 5 is greater than max. So I give that array of I as the max. Then again continue. Now I go to the next. I see whether array of 5, which is 5 is greater than 70. It's not, so the condition fails. Again I loop around. Now 70 is no lesser than any value. So obviously that is the highest value which I have. Simple logic. So it may look very complex in the flow chart for you at this point of time. If you look at the same thing here, it may look very complex. But look at the code. It's pretty simple. In fact, when I now visualize the code to you, you will find it pretty simple. Now see this. Next. So this is the array. Now max is 3. The loop continues. Array of I is 5, right? So that value it will read. Array of I is 5. So the condition is satisfied. So max will become, okay, already it has gone. Max has become 70. See this. Now let me run this again. So here the loop has to run. Cool. See. Okay, then again, so could you see the arrow moving up and down. I'm checking and finally it says 70 is the highest value, it prints. Got it? Simple, guys. Let me go to the next one. Find the factorial. Factorial means what? Primarily, fine, it's calculated by multiplying all positive integers. If I give 5, I want to find the factorial of 5, then it is multiplication from 1 to 5. So you can see here 5 into 4 into 3 into 2 into 1 equal to 1205. So this what, right? And how do you calculate the factorial? Here it is. I am using a while loop and then here is the logic. So this also it will be very easy if I am going to put it in the visualization. So let me take the factorial code. See this. So here I have my, so I have defined factorial equal to 1, I equal to 2, two variables, int n equal to 5. This is the number for which I want to find the factorial. Alright. So 5 into 4, 4 into 3, 3 into 2, 2 into 1. Fine. So here I am just checking if n is equal to 0, n is equal to 1, then just print the number n. Or else while I is lesser than or equal to n. So factorial equal to factorial into I. So I value right now is 2. So fact is 1. 1 into 2. Then I plus plus I am doing. So I is lesser than n. I has become, fine, 3. 3 is definitely lesser than n. So fact equal to, already it is 2, right? 2 into 3. Now I will become 4. So again lesser than or equal to 5. So, right? So that will get multiplied by the factorial. So it will go till 5. Let us visualize the code. So you could see here. So while I is lesser than or equal to n. Right? So I plus plus. You could see there I will become 3 now. Right? So factorial is 2. N is equal to 5 is fixed. Now again, now factorial will become 2 into 3. 6. So I will become 4. Now 6 into 4. 24. Now I will become 5. So 24 into 5. 120. That's it. It comes out and prints the value 120. Got it, guys? Am I making sense? Fine. Fine. It's not 1205. It's separate one more. Okay. So 120 is the answer. Correct or not? So this is your factorial. Now let me congratulate you guys. We have completed the first chapter. See, this first chapter has so many things being covered. Let me just have a glance of what we covered. Please have patience to look at this. See, this was the chapter which we wanted to learn. So variables, initialization, iteration, data types, flowchart, sanity of data. Now you saw the data, how important it is. So we have covered the basics of programming. By now you would have understood what is programming, what is conditional constructs, what is looping constructs, what is flowchart, how algorithm works, and the basics of data science, the basics of computational thought process, the basics of flowchart. So many things we have seen. Now all these things I'm going to again cover in one more video to make it simple for you in a comprehensive way. Now only after that I'm going to go for the next chapter where we are going to talk about find more complex stuffs. Of course we have seen all these things, find max and min, and operator, all these things, correct or not? Though we have touched upon chapter 2, still I won't say I have finished chapter 2. I have only finished chapter 1. See, even in this chapter 3 also we have covered a little bit, but believe me, we have lot more to learn in the basics, and we are going to go little advanced so that you can solve complex problems. Because in the computational thinking paper you will be given an algorithm, you will be given a pseudocode which you need to debug, which you need to dry run, and where you need to say what is the result of that. Now for that we need to have a sequence, we need to learn it. Now what I have done is I have haphazardly taught you the entire first chapter in the way I wish, but again that's not the way education works. Education works by repeating the task. Now I'm going to release one more video on this chapter 1 itself to make it more concise, to give you a clear picture on this particular concept called programming. Now you got to listen that also. Once you are comfortable, then I will take you to the next chapters where we are going to make it useful for you to understand and solve complex problems. So one chapter with different angles you are going to learn. So please understand, guys. Education is not just about learning. I always say education is all about questioning. You got to question. You got to ask questions. Now, so many questions should have raised in you while listening to these videos. Now, I should answer those questions. I should make it, more simpler to you. I should ensure that you enjoy learning and asking questions on this particular topic. So my idea is, after you complete this computational thought process, you should have a clear-cut idea on algorithms, flowcharts, basic programming constructs, data science, and also dry running a pseudocode. So you saw the dry run of pseudocode now. Any kind of pseudocode given to you, you should be able to debug that. You should be able to dry run that. You should be able to visualize that. And you should be able to solve the problems. So once again, welcome to this IIT-BS Computational Thinking subject, guys. So we have just done our exercise with respect to level 1 of learning. The same chapter we are going to do level 2, level 3, like that we are going to go, where we are going to make you think and understand better. So as of now, thank you very much and see you soon in the next video. Thank you, guys.